Good afternoon, everyone. Hope you have a good day or good morning, wherever you might be. Hope you're having a good day so far. Welcome to our OneElect New Kids on the Blockchain webinar. I'm Blaize Stewart, and I'll be hosting this webinar today. I'm Blaize Stewart, as I said. I'm a senior consultant at OneElect and a Microsoft MVP, Microsoft Server Trainer, and a partner cloud solution architect with Microsoft as well. And I'm venturing out into the blockchain world these days uh, to communicate what you can do with it and hopefully communicate how you can get started with blockchain technology and what it's all about. So that's kind of the topic for today. So let's go on. So a little bit about OneElect. OneElect is a consulting company as well as a instructor-led training company. We also have an on-demand training through OneElect Now. We are a gold partner with Microsoft, so we have deep partnership in the Microsoft space, and we're also a Docker partner, and we've had several awards in that from Microsoft, including Microsoft's Partner of the Year in 2016, and we've also achieved many of the gold partnerships with Microsoft through our competencies in DevOps and Azure and several other ones, including Xamarin. And you've probably heard about some of our books. If you have been around in the tech industry for a while, you've probably read Jeffrey Richter's Core CLR book. It's kind of the go-to text on that. And then there's other ones like Jeff Procyse's MFC book. And then now you have several other books that have been published by OneElect guys and many other books that are out there and articles and blogs and so on. Now, to get started with blockchain, I wanted to throw this slide out there. It was just a little bit of a little fun to start off with. Sometimes you might feel like one of these characters in the Dilbert cartoons that I have up here. And up here you have Dilbert's boss talking about, I think we should build a blockchain. And then Dilbert's like, does he even know what he's talking about? And he says, what color would you like your blockchain? He's like, I want mauve because it's has the most RAM. Or maybe it's this pointy-haired lady, as I think I like to call her, on the bottom, and then the marketing guy. And he says, maybe you can, I'm in marketing. Can you explain that in terms I can understand? She says, I kind of doubt it. And he says, because you're a bad explainer, right? And it's really not, neither one of those are true. Blockchain technology is it's a complicated technology. It's not something that you can't understand, though. So hopefully at the end of this webinar, you'll at least have a decent handle on it. Maybe you can get started working with it some too. And maybe I won't be a bad explainer and through the course of this video. But in any case, let's dive right in and talk about what is a blockchain. You have to pardon my cheeky New Kids on the Block references here, but given the name of the webinar is New Kids on the Blockchain, I thought I'd sprinkle it with some references to New Kids on the Block through the course of this. In any case, blockchain, as defined by most sources, would describe it as a distributed database or a distributed ledger. And we're going to unpack what that really means. And in that ledger are blocks that have transactions that are stored securely using cryptography. So it makes a blockchain, quote unquote, tamper resistant, secure, and verifiable. And as we walk through this presentation, I'm going to unpack a lot of what that terminology is getting at. But I'm not going to be talking about Bitcoin and ICOs and all that hype that the media is throwing out there because of what Bitcoin is doing is becoming insanely valuable and just going up and going up and going up, and then all the speculations of when it's going to crash and so on. I want to talk about the technology of blockchain itself that undergirds Bitcoin and all these cryptocurrencies that are out there, and show you how it can be used for more than just a get-rich-quick scheme or a Ponzi scheme of sort or something like that. I'll show you how you can use it in real world business applications in your business. So the first thing that you have to understand with blockchain technology is this idea of the ledger. Now, a ledger is not a new idea. This has been around for many generations. It's basically a ledger is a set of records that are recorded in chronological order. Now, the records are, generally speaking, when you talk about a ledger, are financial transactions. And if you have an accounting package or something like that, you'll have the general ledger in that accounting package. But in the case of the blockchain, it's not specific to financial records. It can be any kind of data. The data is really not the point. It's the how the data is recorded that makes it a ledger. And here I have a little example of a ledger just to kind of give you an idea of how a blockchain works. So here we have let me get my highlighter here. Here we have just a record. Let's say I called it TXID of 100, and it gets a timestamp on it, and it gets a hash from the previous record. And this is just some data that's written to this record. That data can be anything arbitrary. Now, with the next record that comes in, I get an ID of 101. It gets a new timestamp, which should be after the previous record in the ledger. And notice it's got the hash from the previous record in here. This is important in a blockchain because what this does is it allows you to make each record contingent upon the previous record, going all the way back to the beginning of the record. And this is how you get the chain, so to speak, in the blockchain. So what happens when you have that hash is it makes each record pretty much tamper resistant, to where you can't really modify the data without messing up the entire chain that comes after it. So this was what makes a ledger in this case verifiable. So anytime I add a new record to the blockchain, the process, it goes back and calculates the hash on the previous record, goes all the way back to the beginning of the chain to make sure that that data on the new record that's added to the chain is indeed reflective of the chain. So, and it doesn't allow me to go backwards in time and change modified data. Unlike a database where you can update any record, you can only add new data to the ledger in a blockchain. You can't modify old data, but that doesn't mean that you can't modify states, and we'll talk about that later on, and so on and so forth. So once you have a new record, with each one, you get the hash from the previous record, and it just keeps going until you stop using the blockchain. So that's basically the way that the blockchain works on the ledger. Now, there's some other things that we're going to talk about, but this is the most fundamental concept in a blockchain. Now, when we talk about blockchain technology, you hear this idea of a distributed ledger, and it takes that idea of the ledger and then spreads it out across a variety of nodes, and these all become points on the blockchain where things can happen. And the reason it's distributed is because there's no central authority on a blockchain. No one owns the data. It's a collectively owned data. So traditionally, we've thought about doing things using something like a clearinghouse. Think of this like a bank, or maybe eBay or something like that. These organizations facilitate transactions of sort. Think about when you go to bank, make a deposit in a bank, you take your paycheck, you deposit it in the bank, and that bank holds those funds, and then you write a check, or you swipe your debit card, and it takes some money out of that bank and sends it to another agency. But at that point, everything is done by way of that bank. Or think about when you sell something on eBay, you list your product on eBay and a customer buys it on eBay, and that whole transaction is facilitated by eBay. So there's a central ledger, if you will, at eBay and at your bank that controls all the data. And so if you want to interact with anybody, you use that central clearinghouse, and rather than using what we'd call a distributed ledger, which is essentially what a blockchain is. Notice that there's nothing here in the middle. There's no centralized ledger. The reason why this works is because everybody on the blockchain, everybody has a copy of that ledger. So I have a copy of it here, I have a copy of it here, here, and here, and I can interact with anybody else on the ledger. So if I want to interact with each one of these, I want to do business, horizontally rather than go through a middleman, I can do that now. That's why the blockchain technology is called distributed. Now it's more of like a peer-to-peer network versus a centralized database. And so when we talk about having something distributed across nodes on that network, we're having every computer that has the blockchain running on it has some kind of software, and it communicates with all the other nodes. It can process the transactions just as easily as any other nodes and verify the transactions just as easily as any nodes. It also makes it rather fault tolerant. So imagine the bank system goes down. Well, no, you can't do business. Well, with a distributed network, that's no longer a problem, because if one node drops off, you still have every other node on the network that is currently running. So it makes it fault tolerant, distributed, verifiable, and so the trust relationship is no longer no longer needs to be brokered centrally. It can be brokered by trusting in the network itself rather than a centralized authority. So that's one of the biggest differences between a distributed ledger and a traditional ledger or centralized ledger that we might have been used to. So keep that in the back of your mind, because as we talk through this, it's going to have implications on how we can actually use this in business cases. Now, with a blockchain, you have this idea of mining. Now, blockchain mining is kind of the buzzword. You hear like mining Bitcoin or something like that. No one's going out there and swinging a pickaxe at the ground trying to dig this stuff up. That's not what it's talking about. Mining is just the idea that you're actually processing data on your node. So if I have a blockchain miner, it might look something like this. These are commercially sold now. I could connect this to an internet connection and then configure it to mine stuff on Bitcoin or mine stuff on Ethereum. And what that's doing is it's processing transactions and validating new blocks as they get added to the blockchain. And with that in mind, every time I validate a block or I add a new block to the blockchain, I get credit for doing that work and I get rewarded with coin. That's where the idea of Bitcoin comes from, or some other form of cryptocurrency. Now, not all blockchains use this reward system because it's not required in all blockchains. Most of the time, this is true in public blockchains. You have a coin that is rewarded, but in what we call private blockchains, which you can set up with some blockchain technology, this becomes a really kind of a irrelevant idea at that point. It's not necessary for the blockchain to work. Really, the main thing about a blockchain to understand is the distributed ledger portion, not so much the coin portion of the cryptocurrency, unless you're going to be working on a public network like Ethereum or blockchain or something like that. But in any case, that's what mining is. Now, you don't have to, you can do mining without being rewarded for it. And that's essentially anytime you process something on the blockchain, anytime you run some kind of contract, which we'll talk about in a minute, or you process a transfer of some asset, or you change a state on the blockchain or something like that. So what does the process look like? So step by step, the transaction process. A transaction is requested. So this is what happens whenever you do something on the blockchains. You start a transaction request at some point, at some node on the blockchain. That can be any node on the blockchain. It doesn't matter where that originates. Then after that transaction happens, that transaction gets broadcast to the nodes, and then the nodes have an engine that decides who on the node is actually going to handle that transaction. That's who's going to mine that transaction, who's going to process that transaction. And after that election process happens, that miner verifies the transaction. So it actually executes whatever is needed to verify the transaction. And then that miner then takes that new block of data and adds it to the blockchain. Now, the blockchain then is distributed back across the network, and everybody gets a copy of that new block of data. And so that one miner gets credit for processing it, and then everybody gets a copy of what he processed. And so that is now distributed across the network, and he is the one that gets awarded the Bitcoin if his node is the one that processed it. And then finally, the transaction becomes transactions are combined to form new blocks on the blockchain. Now, when I talk about transactions, this is the process of actually processing something on the blockchain, and the blocks themselves are where that data is stored once you have the transactions completed. And multiple transactions will form a block. Sometimes there's a one-to-one relationship between a transaction and a block, depending on what technology you're talking about. But in any case, the block is just the storage unit. The transactions are the actual exchange that takes place on the blockchain. So that's basically how the transaction works in a very elementary presentation. I mean, there's a lot more that goes on under the hood, obviously, but with how that happens and the technical details, but it's really not the point. Just to understand that the broadcast happens, it elects a node to process it, that node processes it, adds it to the blockchain, and then that transaction is then written to the blockchain and becomes a permanent part of it for as long as that blockchain exists. So I want to do a little bit of a demo here, just to show you how you can use blockchain technology right on your desktop. So if you're interested in running a blockchain, you don't have to go out there and sign up for Bitcoin. You don't have to have any of that. You can actually run like a development blockchain a GUI-based tool on your desktop to just poke around at it. So I'm going to do just that. I'm going to launch this one. It's called Ganache. Ganache is the evolution of a long work in progress from a group called that produces tools for developing technology for producing. You have to excuse me a little bit. I'm coming down with a cold. Ganache is a tool that is the first of as the last in the long evolution of a set of tools that's been developed by a group that develops tools called truffle. And truffle is, obviously a sweet dessert, and Ganache, if you're familiar with that, is similar to a truffle. And this is just a development blockchain that allows you to write code and process transactions and other things while you're developing. Now, I'd never use this in production, but it does illustrate the point. Now, on this blockchain, you see that I have a list of accounts here, and we're going to use it. And accounts are what are used to store your your currency, whatever that may be. Now, in this case, I'm using Ethereum, which Ganache is based on. So I've got 100 Ether in all of my accounts. Now, and these are all the addresses. Now, these are not on a public blockchain, so you couldn't take my addresses here and do transactions with these on the public Ethereum network. These are only resident to my local instance here. But I can do anything on this blockchain that I could do on the public Ethereum network. And so if I'm going to write software on the blockchain, this is what I would use as a way of developing and testing that software. And I have accounts, I have blocks. Currently, there's none on this. And I have transactions, and currently I have none of this either. So to do that, I'm going to put some data on this thing. So what I'm going to do is I'm going to come over here, and I'm actually going to run a script on my screen. And let's see what we have here. Let me open up a command prompt, and I'm going to run a script off screen so that we can see some transactions get added to this blockchain here. So I'm going to go, and if all goes well, we should see a couple transactions appear on this blockchain. Now, this I just ran a script, and it did 10 transactions on the blockchain right here. So now I have one transaction for each of the contract calls that I did on this blockchain. Now I'm going to talk about contracts in a little bit later on, what that means. And you'll see here that this is the hash I was talking about, the transaction hash that gets for this transaction, and then that becomes a part of this transaction, when this then becomes a part of this transaction, and so on. I'm sorry, these are in reverse order. This one happened last, so this one's got the transaction of this one, and then so on and so forth, going down the list, not up the list. And if I click on this transaction, I can actually see the what happened. And this is the data. It's encoded in hex. But if I took this into a hex editor, in fact, I think I can do that. Let me pull up a hex editor here. I can you can see some data that's been written. Let's see, online hex editor, hex string editor. There's one, and let's click on maybe this one. Paste in some data, and yeah, there you can see some clear text. He's got 5 stars because he's handsome. I'm going to show you an app in a little while, and that's some of the text that gets written to that app. But you can see this is in clear text on the blockchain. So anybody that has access to the blockchain can see whatever you write to it. And this is what makes it verifiable, because everything in the actual blockchain data is now part of that block, that blockchain ledger that gets distributed to all the other nodes, and it's publicly accessible by anybody that can view the blockchain. And that's one of the things that makes this open platform appealing to some businesses, because it does give you transparency into the transactions themselves. And we'll talk about some of the caveats of using blockchains later for privacy and so on. But just so that you know, yes, the data is in clear text on the blockchain, and anybody can see it. And just like this block, I can see any of these. I can come over here. I am doing a one-to-one relationship between the blocks and the transactions. So if I click on this block, it shows me the transaction that I just viewed, and then I can drill down on that transaction. I can see it again. So Ganache is a really cool tool if you want to kind of play with blockchain without actually having to go out there and sign up for a blockchain online, or trying to use some command line tools. It's a GUI-based tool. You can download it. It's available for Linux, Mac, and Windows. And it's really fairly intuitive to use, and it's great if you're going to be writing what we call smart contracts later on. Someone had raised their hand. If you could pose questions later on, I will take those late towards the ends of the presentation, and we'll talk about that later on. There's a section in there where you can actually pose questions, if you will. So let's go back to the deck, and let's see what's on next on the agenda. I want to talk about this idea of wallets. Now, a wallet in blockchain technology is essentially the analog to what you carry around in your pocket, and it's basically a way to secure the accounts for the coin that you own. Now, in the case of blockchain technology, there's wallets that are dedicated to whatever blockchain you're using. So in the case of Ethereum, I would use something like MetaMask, which I'm actually going to demo here in a minute. And what that does is it gives you a way of a portal into all your accounts. So you can have multiple accounts and you have one wallet that manages these accounts. So this is the way that you would kind of, the GUI tool that you can use to send cryptocurrency back and forth between other accounts on a blockchain. Now, again, if you're not dealing with a network that has cryptocurrency, then a wallet's really not that important. But in the case of Ethereum or Bitcoin or so on, you would need one of these if you wanted to secure your accounts and have an ability to work with those and what have you. So let's do a demo of MetaMask, which is a wallet app for Ethereum, and it's actually browser based. So I'm gonna pop this open. It's a Chrome extension. Currently I need to attach to my network here, and I want to send some coin between this one, between one account and another one. So currently I have 99.99 Ether on there, and that's, if it was actually worth something, that'd be worth about $53,000. I don't have that much Ether. This is because I'm using Ganache instead of the public Ethereum network. But in any case, I want to be able to send currency between two accounts. So I can do that. I can demonstrate that using MetaMask here. Let's go back to my accounts. I'm going to transfer currency between, let's say I'm going to transfer between to this account here, because what I did is I added this account here to my wallet. If I can highlight the address, this account, and what I want to do is I want to transfer money or transfer Ether, that's the cryptocurrency, to another account. I can do that rather simply just by going to send, and so I can do is send, pick the address, pick the amount I want to send. Maybe I want to send 15 Ether, and then submit that. Gas price must be equal to, let's see, that's 55. That one didn't go through. Let's try that again. Let's post that again. 15 Ether, next. Let's go. For some reason it's not working, but okay. I don't really have the time to debug it either, but in any case, that's how it would work if it was working at the moment. I'm not sure why the MetaMask won't let me transfer the Ethereum currency. Let's refresh this account just to see if that's the problem. And let's just import an account and see what happens. I can use the private key, and let's use this account here. Now the private key is available on this one, but I would never do this on a public blockchain and broadcast that, because that gives someone access to my account. Maybe I can add this one in, this account in. No, okay, that's better. Now I'm going to try and send it to account number to another address. Let's do it to maybe this one down here, and paste this address in. Let's try to 15 Ether. And submit. Okay, that one looks like it went through. There, now we have, that one's got 1,515, and this one got 85 now, or roughly 85, because it did have to spend some currency, spend some Ether to make that transaction. So roughly, so I transferred 15 Ethereum, or Ether from one account to another using MetaMask. So that's how a wallet works. It allows you to do transactions and facilitate just the transfer of currency. Now, if you come over here and look at the blocks, you now see I have some new blocks on here. This one is the one I just did with the transfer of currency between two accounts. And you can see here I have a new transaction on here. It's just a value transfer between two accounts. And so that's a way of doing that on blockchain. So I have a contract call, which we're going to talk about in a minute, but this one I just did a value transfer, which is a nice way of trading money without actually having to do contracts, which which are the actual apps that you write on the blockchain. So that's wallets, what they are used for and how they work. Let's go back to our deck for a minute, and now I want to talk about smart contracts, which I've alluded to a couple times already. Now, a smart contract is essentially an app, for lack of better words. It's a code that runs on the blockchain itself, and it's called by way of a remote RPC, or remote procedure call. Now, contracts offer both ways both to process, store, and retrieve data from a blockchain for custom use cases. Now, this is how you make a blockchain this is how you make a blockchain address your use case that's specific to your use case, but use the generic technology that's available from the blockchain. So the smart contract is your code, then the blockchain technology is what undergirds that smart contract. So the way to think about a contract on the blockchain is just a part of it, becomes a part of that blockchain when you add it to the blockchain. So in the case of the smart contracts that I'm about to show you, once I deploy that contract on the blockchain, I cannot modify that contract without messing up everything that's been used to process everything that smart contract has processed. So you have to make sure that these things are basically bulletproof before you put them in production. Then that's another reason why you want to keep them simple as well. But the idea here is that once I put this contract on the blockchain, I can execute code on that blockchain in a similar fashion than where I transferred money back and forth, but that code can be used to do things like validate states of particular transactions. Like suppose, for instance, I'm going to do an application that that allows me to sell an item online, and part of that transaction is I as the buyer need to verify that the phone or the device that I bought online has been sent. And a part of that transaction, I go online and I say item received, and as part of that contract process. But before that item was received, the seller would have marked that item as shipped on that particular transaction. So the smart contract, what it does is it has ways of marking a particular contract particular transaction as it walks through each step in the process of that particular transaction. Now that can vary. I'm talking in generalities here, and I have some use cases I'm going to talk about later on. But the idea is that the contract, the app, is got the code that can actually handle that. It can validate the transaction and the steps and make sure everything happens in a particular order and so on and so forth. So with that in mind, I actually want to do a demonstration of a contract on my little development blockchain right here, Ganache. So I'm going to reset the blockchain here. I'm going to come over here to this button and restart it just to refresh it. And I'm going to pull back over my terminal here. And this terminal is where I'm going to do some work here. I'm actually going to deploy a contract to this network, and then I'm actually going to execute some code using that blockchain, that smart contract on this blockchain. So let's go back over here to the transactions tab, and currently you see there's nothing there. So in my command prompt here, I'm going to do a cd rate my prof, and this is called a rate my professor app. So it's like a voting app, so that the vote gets permanently added to the blockchain whenever it happens. I'm going to show you the app in a minute, but essentially it allows you to write your vote on your professors using a star system, 1 to 5 stars and so on. But with this in mind, I can deploy the contract to this particular blockchain here using Truffle, which I mentioned earlier. Truffle is the command line utility that allows me to deploy a blockchain. Now I'm going to specify a reset, because I want to reset it just in case I have any residual data. And then I'm going to specify the network that I'm going to be deploying it to. So I've got a network defined as Ganache, and Ganache is it's the nickname that I gave the development blockchain here. So if I run this, it should compile and deploy my blockchain to the network there. So you can see that it just did a few transactions by deploying that smart contract to my network here. Now that contract is ready to use. So with this in mind, you can come back over here and look at the actual transactions that were called. Let me pull this up. You can see I have a contract creation here and a contract creation here. This first contract creation was a deployment script. It is essentially deployed a contract to deploy my contract that I'm interested in using for my app. And then it called the contract with some parameters. Then it deployed my contract, my custom code, that then was deployed to the blockchain itself. Just to show you what this might look like, the code is fairly straightforward. Here's the actual code. It's using a language called Solidity, and that language, and it looks sort of like C, or maybe looks sort of like C, maybe JavaScript in some ways. It's a fairly limited language what you can do with it. It's not as powerful as either C or JavaScript, but it does allow you to do things on the blockchain. And this one I have several methods that I'm going to be calling just to show you. I can add a professor, I can add a rating to a professor, and then I can get a professor count, and get a professor, and get a professor rating. So those are just 5 methods on this particular smart contract, and this has now been deployed to my blockchain. And so I'm going to execute this code. But the way I'm going to interact with this code is I'm going to actually use a front end for it as a website. So think of this back-end smart contract in the way that you would think of a database. And maybe this is where the database, the transactions are happening on the database, is what happens in my smart contract. It's kind of the analog. This being maybe a 3-tier application. The smart contract is the bottom tier, is the data tier. And the middle tier would be a node app, just a simple node app that I've got wired up to interact with that contract. And what it does is, in several of the methods, it's calling out to that contract by way of remote procedure calls and passing in parameters to that contract using, this is just Node.js. You don't have to write these in Node.js, but you can write these in .NET, PHP, Java, what have you. The front end doesn't really matter as long as it's interacting with a back-end blockchain contract, in this case written in Solidity, running on Ethereum. So that's my middleware, middle piece. Back-end would be the smart contract. The middle piece would be the Node.js app, and then I'm going to actually load up my other one in just a second here and show you what these actually look like whenever they run. So let's flip back to my command prompt here, and let's actually launch this thing and deploy some data to this smart contract using my Node.js app. So I'm going to go up one more step here, and I'm going to run node index.js. Now what Node is going to do then is it's going to launch this, and it's going to seed my app with some data. So part of that Node.js app is a routine that checks for any data on the blockchain for my particular smart contract to see if there's any data. If there's no data there, then it will add some data. So it's going to seed some data on this contract. Let's see if this will work. Okay, it's adding some data. So I added 5 professors in this Rate My Professor app, and then I added 1 comment and star rating for each of my professors I added, some Jeff, Jeffrey, John, Todd, and Blaize. Now that's running as an HTTP app. So this is the middle piece here. Here's my blockchain in the background. You can see I added a whole bunch of new transactions and a whole bunch of new blocks to my my blockchain here. So let's open a browser window, and let's go to localhost 8080 and see if this pulls up my data here. So there is the data I added to the blockchain. I added each one of these guys, Jeff Procyse, Jeffrey Richter, John Robbins, Todd Fine, and myself, to the blockchain as professors, if you will, in this Rate My Professor app. And now I can go into each one of these and say with Jeffrey Richter, I think he's a great guy, but I didn't like his class, so I'm going to give him 3 stars and say maybe I shouldn't give Jeffrey Richter 3 stars. He's a really smart guy. So he is a smart guy, and I can add that to the blockchain. And now this is I've got this record here that's been added to the blockchain. No, I had 14 before, but now I have 15 blocks and a new transaction that I just called by way of a web app and stored that on the blockchain. So if I was going to pull this code back into that text editor that we just saw, online hex string editor. Let's pull that one I just had up. There we go. I can, yeah, he's a smart guy. That's the code I just added. That's the comment I just added, and that's the encoding of the star rating that I did for him on this particular transaction. So it added this comment right here to the blockchain as a transaction. So now you can see that I can use a web app to store, by way of a Node.js app, store data on the blockchain. Now, it is possible to write apps that interact directly with a blockchain by way of JavaScript in a web browser. It is possible to do that. There's some use cases for that. Now, not every use case is going to lend itself well to that. Some will, some won't. But we can talk about the technical details of that offline. But it is possible that you don't need that middle tier. You can interact with blockchains directly from a browser using some JavaScript libraries that are available. But just so you know, in most cases, you're probably going to need a middle tier because blockchain technology is not a replacement for remote database management systems. And there's some technical reasons why we would talk about that. But in any case, just so that you know, you can do that. So let's go back to the deck and let's talk for a little bit more about some use cases. Now, this is probably the canonical use case for blockchains. What blockchains have been envisioned for is any myriad of use cases, but this one is kind of one of those canonical use cases. If you can think about a supply chain. Now, supply chain, if you're not familiar with that concept, is the idea that you have vendors that buy things and then make things. So if I'm manufacturing a smartphone, for instance, I need to buy components to put into that smartphone in order to produce that product. So what we have then is a supply chain. You have everybody that on that chain, from the guys that actually mine the raw resources and make, to the people that make the components, to the people that manufacture the phones, and then the people that actually manufacture the packaging for that phone, and then all the way down to the people that actually buy the phones to sell it into the retail outlet. Then finally, the last person would be the consumer that actually buys that phone off the shelf. So in that entire supply chain, you have a lot of steps involved in that. Now, the idea beyond the supply chain is the ability to trace from beginning to end where a particular piece or component or something came from. So it's, suppose I mined some lithium in Africa and I shipped that to a processing plant in Mexico. They created a battery. That battery then gets shipped to a plant in California. They manufacture the phone with parts from all over the world, and then that phone gets packaged and then shipped to a Best Buy in my hometown in Richmond, Virginia, and I buy it from them. I want to know where that battery came from, or suppose there's a recall on the battery or something like that. Well, we can go back and we can look at the supply chain and see where all those resources came from, or where those particular components were manufactured, and I can know who bought what and so on and so forth. So if I need to do recalls, or I need to inform a consumer that there's a potential problem with the product, or so on and so forth, or if I just as a consumer want to make smarter decisions, I have traceability and I have transparency into that supply chain. Now, the reason that's difficult now is because no one in the supply chain management business has a centralized ledger. I'm sorry, everybody has their own centralized ledger for their particular point in the supply chain. There's no one database that's shared among them. So I, as a consumer, have no transparency and I have no visibility into that product, into that supply chain. I just have to essentially trust the fact that maybe Google or Apple built that phone and built it in a way that it's not going to explode in my pocket or something like that. But in any case, what the blockchain would do then is, if everybody in that supply chain has access to the blockchain, then they can write to that blockchain when their transaction happens, and they can also note the transfer of resources and transfer of ownership on that supply chain from one seller to the buyer, and then that buyer then turns around and becomes a seller, and then on down finally to the end user or the consumer of that product. So that's one of the the canonical use cases for a supply for blockchain technology. Another one that is it's kind of an idea that that might be a possibility for blockchain would be like, suppose a very familiar experience if you've ever bought a home. And if you've ever bought a home, you know what that process is like, and all the paperwork that's got to go through, and all the involved agencies that are involved with that. Think about insurance agencies, real estate brokers, real estate agents. You usually have multiple brokers, multiple agents. You have a buyer, you have a seller, you have mortgage companies, you have insurance companies, you have government agencies, and mortgage underwriters, and all of these different agents that are working on a particular contract. Now, of course, there's some PII issues with this particular use case. You wouldn't want to put things like social security numbers on a blockchain, but you could put things like the transactions themselves on the blockchain, which ultimately are public records, like the transfer of deeds, the real estate listing, the real estate contracts, these kinds of things. That you don't have to put the names on there, but you could say that part of the process and the transaction of buying a home is completed. So and so paid me escrow money, or I was able to get the underwriting taken care of. And as you advance the home buying process along, and you could use a smart contract as a way to say, hey, the buyer has secured the funds to purchase this home, or hey, the listing agent has been paid their listing fee, and or the seller's agent has been paid their commission, or something like that. You have all of those various components that are part of that process, and a blockchain would be a good way to handle that. If you didn't, of course, put the personal information on there, but it could help facilitate that process where everybody has transparency, and you're not dealing with all this paper, these stacks of paper and telephone calls and emails and all that arduous process that goes into buying a home. If you've ever done that, you know what I'm talking about. So, of course, there are some things that you wouldn't use a blockchain for, and I want to mention a few of these. As a It's not a replacement for an RDBMS, or remote database management system, like a SQL Server or so on. While a blockchain is useful for storing data, it's not a replacement for that data, for a remote database system. Now, in the case of a blockchain, what you would want to do is you would want to be able to have the data that you need on the blockchain without having to upload the entire data set to the blockchain. So in the event of, like I was mentioning a minute ago with the home buying, you don't need everything about that home buying experience on the blockchain. You just need the necessary information to show that the process is moving along, and you can use your backend systems to interact with the blockchain in the way that my smart contract and my Node.js app did, and that little demo app I did a few minutes ago. It's also not a messaging solution. Like it's not really useful for doing things like what we do is like an MQTT server or something like that, or a service bus. Now that the service bus, lets you trade messages using a pub sub, asynchronous pub sub model. If you're familiar with that pattern, you could theoretically do that with a blockchain. However, it would be incredibly wasteful use of resources, because every transaction, everything would be written to the blockchain. And if you don't need that level of verification and so on, it's not going to really serve you well for that particular use case. So consider using something else like an MQTT broker or a message bus for that. And again, as I've mentioned again in the previous use case, you wouldn't want to store personal identifiable information on their PII data, like social security numbers, bank accounts, credit card numbers, and so on. However, that doesn't mean that you can't store information about transactions that use these things on a blockchain. So that you could tie transactions at your bank to things on a blockchain is certainly a use case for blockchain technology. And of course, for non-essential data, you would never want to store something that is not essential on the blockchain, because if you're using a public blockchain especially, the non-essential data is going to cost money on that blockchain, because storage isn't cheap on a blockchain, the non-essential data should not go on there. So it's just what you need to make sure that the transactions happen. Any more than that is really considered superfluous on blockchain. You don't want to do that. So kind of keep it to the minimal and don't add anything beyond that. So again, blockchain technology is not a standalone technology for applications, more of a way, an intermediator between different applications, such as like my Node.js application. If I had a database management system behind that, as well as a blockchain, I could use those in conjunction. My blockchain is how I facilitate transactions with other applications for folks that are on the blockchain, but they're going to have their own backend systems as well. So that's kind of the point there. So that's kind of sums up the technical presentation here. I have some time for questions here. It's about 2:45. I do want to take some time for questions, and so if you have those, please pose those questions. I'm going to pull these up right here. And a few other things you can do is you can follow me on Twitter at the One Mule, or you can let us help you with your blockchain technology, or you could let us help you with your or let us train you on blockchain technology, and we have those kinds of things. First question to ask is, can we download this webinar? Yes. This webinar will be recorded and we'll be posting it online, and we'll be definitely posting that out there for future use. And we'll have that available. We should be on. I look for it in the next week or so if you want to review this webinar on blockchain. Do I have the source code for the Rate My Professor app in GitHub? It will be in GitHub. It's not. It's not. It's currently going through. It will be published on GitHub, and I'll talk to you. I should be able to give a link to that in the future. Pay attention for that link on the post whenever we get this video up online. Definitely look for that source code. It's a fairly basic smart contract though. I do want to put that there. Questions are rolling in now. This is good. Keep them coming, please. Let's see. Third question is, what is the retention policy of a blockchain, and how much data can I is involved in the system like Bitcoin, and how fast is the size increasing per day? I don't really have metrics on how fast the data sets are growing. There are limits on the Bitcoin blockchain, and there's limits to the number of blocks on Bitcoin. Ethereum, depending on different technologies, Ethereum I don't think has a theoretical maximum, so it's really limited to hard drive space at that point. The retention policy for a blockchain is forever. That's kind of the point of it, is so that you can go all the way back to the beginning of the blockchain. From day one of when the blockchain was created to the day that you shut it down, the retention of those records is forever. And that's kind of the point of having the blockchain, is because that's what makes it verifiable. You go all the way back to the beginning of time for that blockchain and check everything in that blockchain and so on. Third question, excellent presentation. Thanks for taking the time to put this together for us. I'm assuming that the performance is faster due to exclusion of mining. On my local blockchain, I assume that's the nature of the question. Yes, it's the mining process, because the development blockchain I'm doing here isn't mining active blocks in the background. It just does them as they need them, rather than actually discovering new blocks, and which is typically what a blockchain does, and which is one reason it does perform fairly well. But if you want to create a high performant blockchain, you would want to create a blockchain with multiple nodes on it, and have particularly in Ethereum, you would have transaction nodes and you have mining nodes. And transaction nodes on the Ethereum network, the more of those you have, the higher performance you're going to get. And so you can go out to Microsoft Azure and spin up an Ethereum network there that's got 2 mining nodes and a transaction node, and it's decent performance. It's not great though. Can you discuss the smart contract code you executed on what host in response to what events? The smart contract code is something that I wrote. It's just a simple. It's called Solidity. I didn't want to go into the technical details of that, but it's essentially what happens with that code is it's a JavaScript-like code. It gets compiled into a bytecode that is executable by the Ethereum VM. And so what happens is that code gets compiled, and then when I did that deploy, it takes that bytecode and actually puts that on the blockchain as part of a transaction, and that's what gets executed on the Ethereum VM. That was all running on my local box here. I had the Node.js server running against that Ganache development blockchain that I was running, and the web browser was the client for all that. So it was all running locally. But there's no reason that same scenario wouldn't work on in a production server if you were to put your Node.js app on a server and you put an Ethereum network out there. Can you discuss the smart contract? Does OneElect now offer blockchain training? I think we have IoT training for this. I don't know that we have anything on OneElect now for that. I would look for that in the near future, though. I think we will have something for that on OneElect now in the very near future. Let's see. Scroll down here. Can you recommend a book that covers similar material? I wish there was a good resource on blockchain, and it's starting to come to a point where there are resources. Truth be told, it's rather new. So the resource, I don't know of any good resources that I personally read. Most of what I've learned about blockchain has been gleaned from a variety of sources, including working with it. So I don't really have a good book for it. However, I would go out there and read the documentation for Solidity. They have a fairly good idea, a fairly good introduction to smart contracts and what those are. And go out there and read the Wikipedia article on blockchains and read the Wikipedia article on Ethereum in particular, because I think those are both excellent resources, and it'll give you some pretty good idea what blockchain is. And there's some links at the bottom that'll give you, some pretty good idea what that stuff is too. Where's blockchain data actually stored? It's stored on my hard drive. Where's the database continue? Will the database continue to grow forever? Yes, it will continue to grow forever. In that case, can a blockchain provide a way to prevent piracy of digital media like movies, MP3 files, and so on? I'm gonna have to. I would have to say yes and no. The reason why I say yes and no, because DRM is typically enforced by client, so there's nothing that prevents me from using my device to attempt to break a particular record on a DRM solution. Now, what it can do is it can prove that I actually wrote the original content for that particular MP3 or that particular movie, because if I were to use a blockchain for as a storage for MP3s or movies, that I could put that on the blockchain, or at least the hash of that. I don't think I put the whole movie or MP3 on there, as a way to validate that fact that I actually originated that content, and and also to validate that content by way of DRM solutions. That this is the original solution. So there is probably some use cases there, but it like I said, putting the hashes of MP3 files and using your player to validate that against the blockchain would be a way of doing using that in DRM. But what keeps somebody from hacking that locally and transcoding that into another format? I don't think so. I don't think it has anything for that. How multiple nodes resolve conflicts? That's a good question, and it gets down into game theory. With a blockchain, the idea is that there's an election process that goes on inside of the nodes on a particular network, and that election process applies game theory to it. And then once a node has been elected to process a transaction, it processes it, and then processes that transaction, calculates the hash, and then rebroadcasts that transaction to the rest of the nodes, who then validate it. So all the other nodes validate the transaction by way of the hash, and then by recalculating all the other hashes in the blockchain. So that's how it does. That's how it resolves conflicts. And if there's a bad block added to a blockchain, and there's like a majority of nodes on the network that reject it, then that block will be rejected from the network. So it's kind of a democratic solution within the nodes of the blockchain. So it's an interesting scenario how it works, but it is work. Is a hash of the previous transaction, would the very first transaction have a hash? Yes, there's like a seed hash, if you will. Now, on every blockchain, there's essentially a original hash that is used to incorporate in that first hash, the first block, and then so on and so forth. So everybody has a copy of that original hash, so it's not like it's a secret. And so you couldn't modify the blockchain without violating every other node on the particular block. So yes, there is a root, essentially a root hash that gets seeded for the first transaction, and that also serves as the kind of the start of the entire chain. Can you discuss the gas model for private chains? Where's the gas that has no monetary values is still used? How is it issued? Yes, the gas for Ethereum is used in the same way that it's used on the public network. The only difference is it doesn't have any real world value other than the ability to execute contracts on the private Ethereum network, and so everything. And it's a way to keep people from abusing the network. If you want to use a private blockchain and use Ethereum, the Ether would be a way to prevent people from abusing the network, because if you run out of Ether, you can't do the transactions anymore. Now, it doesn't have monetary value, but gas is still used on the Ethereum network, and it is still issued. It's just that you can't go out there and exchange it for real money or for real property or something like that. How can I have my own blockchain? Yeah, actually, you can have your own blockchain. That's what I have on my desktop, or you can go out there and spin up one on Azure using the blockchain as a service template they have up there. You can create your own private blockchain, or you can run like the development blockchain, just like I was there. Um, is it possible to steal digital coins? Another question coming in. Um, doesn't the blockchain record ensure that the legal owner of the blockchain is always known? It's married essentially to the account. Now, if somebody gets a hold of the account data, then they can actually if they can get into your account, and then they can use your password to transfer all of your coin out of your account. That actually has happened before. And that's one of the weaknesses of blockchain, because there isn't a centralized authority, so there's no like insurance on the coin. So it's more like cash. Once it's been stolen, it's gone. So yes, it is possible to steal the digital coin, but they actually have to get a hold of your account data in order to unlock your account, then to transfer that money or that coin out of your account into another account. But there's really to reclaim that is virtually impossible on a blockchain, though. Based on my understanding of the ledger, is it going to get larger and larger? Yes. Would it cause any issues in the long run with the size of the ledger? The way that a ledger works is that the way it's designed. I know that it looks linear in the way that I showed it, but a ledger, a blockchain looks really more like a tree than it does a ledger than just like a linked list, if you will. It looks more like a tree. So the actual transaction process is actually it's not as long as it looks. So while the data set might grow infinitely large, the actual number of steps going back to the root is rather finite compared to the actual size of the data. So if you actually were to look at the data structure that undergirds it, it's more like a tree. But the idea of a ledger is necessary to encapsulate the idea that you trace it all the way back to using chronological order with the hash from the previous record and so on, going back in time. So, but for all intents and purposes, it acts like a linear ledger, but the actual data structure is more tree-like. Is there some MOOC out there on blockchain for a business? I'm afraid I'm not familiar with MOOC, that verbiage, but is there something out there for business? There's several blockchains that are available on blockchain for business purposes. Ethereum you can have a private blockchain, and there's another one called Hyperledger, which allows you to. It's more of an enterprise-oriented blockchain that doesn't have a currency. It also has a permissions set or associated with it. But in any case, I'm not sure what MOOC means, so I apologize to that question. But yeah, there are blockchains that are oriented towards business that aren't public blockchains like Bitcoin or Ethereum. Mastering Bitcoin, it has good reviews. That's okay. Someone posted a link to a book. Yeah, that's good. Does blockchain branch? If not, is it necessary for every transaction to get copied to every ledger? Like I mentioned a minute ago, there is a tree-like structure under the hood, but for all intents and purposes, it's more or less linear. How can a private blockchain code? How can I create a blockchain code for enterprise government use? How can you do that? It's very easy. Just go out to Azure, and spin up Hyperledger on Azure. Hyperledger on Azure is an enterprise grade blockchain technology that's specifically built for enterprise purposes or government even, and it allows you to have that blockchain available. Also, Ethereum can be used for that same purpose, although Ethereum is more general purpose. As also the public Ethereum network. You can also have private Ethereum networks, but Hyperledger would be an enterprise grade one as well. Can a blockchain be modified if the majority of the mining nodes agree that all the hashes from the modified block be forwarded? I guess in theory it could. I don't. That's the kind of the point though. You don't want to modify the blockchain going forward. Typically with a blockchain though, if there's an error that was posted to a transaction, the transaction of the contract state can be modified, but the original transaction is still available for viewing. So you really wouldn't want to go back in time anyway, because you want to keep rolling that ledger forward, and you just would go back and essentially write the mistake by way of another transaction versus going back and modifying that transaction and trying to recalculate the entire hash on that. I read that blockchains are not anonymous, even though they have private keys. Can you explain why? Um, they're Blockchains are anonymous in this if you were to use like Ethereum or Bitcoin. Um, the trends like there's nothing that says that you have to identify yourself on a blockchain other than the address that you hold. So the data is in clear text. Essentially, anybody can view the data, but the identity behind that data isn't. So that much is anonymous. And you cannot open somebody's account without the cryptography that secures that account, like the private key, like I showed you, cannot be used unless I explicitly unlock the account to fund some sort of transaction. So without that private key, any account on a blockchain is not accessible. I mean, you can view the transactions associated with that, but you cannot actually access the funds in that. You can send money to it, but you can't send money out of it on the blockchain. Are there tools to trace back the transactions? Sorry, I scrolled too fast. Are there tools to trace back transactions on a blockchain? Well, yeah, you saw with Ganesh, I was able to view the entire chain going back all the way to the beginning of time with that. Um, the With Ganesh, I was able to see the whole transaction, so on and so forth. Now, are there tools to trace back a transaction on a blockchain? Yes, there are. Using the command line tools, the geth, which is the ability to view through transactions and so on and so forth. Geth CLI, and there's other tools that allow you to kind of do that, go back in time and validate the nodes as they come in as well. I can't. I think if Geth is the first one that comes to mind for Ethereum, I'd have to look at the one for Hyperledger. But yes, you can do that. That's how the validation of those transactions happens anyway. When new nodes are added globally to a public blockchain, does it slow down the validation process of new transactions? No, it doesn't. All you have to do is get I think a consensus for a new transaction. Once that's added, I don't think it slows it down per se, because the actual validation is not usually the lengthy part. It's the actual execution of the transaction that takes the longest part. So I don't think it does. Can viewing clear text be prevented by encrypting it? Yes, you can encrypt data in the clear text. Kind of the point. Um, Kind of the point though of having a blockchain is transparency. So I mean, I don't know why you'd want to do that, but you can do that. Um, but okay, yeah, it is possible to encrypt data on the blockchain. You could encrypt the string before you write it to the blockchain. Can viewing Okay, thanks. Massively online open courses. I don't know of any out there for MOOC. Blockchain online. Okay, there's some links to. There's one available at Coursera Learn cryptocurrencies. I was making a statement about MOOCs. Okay, sorry. Great, thanks for clearing that up. I wasn't familiar with that terminology. That's something new I learned today. I've heard that a lot about blockchain in the banking, but it cannot be store PII data on the blocks. How does that make sense? Like the accounts themselves, you could store something that's essentially a key value pair that is like, imagine I had a database, in my backend system, such as I have my bank account at whatever bank I'm using, and then in my local database, I have with that some ID that I use on the Ethereum or on the blockchain. Now, I'm not putting my bank account information on that blockchain. However, I can put that key that associates my bank account number on the blockchain, and that way I can have that association with the backend blockchain, and I can use that, and then that can be linked to some other analog with on the other side of the transaction. So it is possible to not store PII data on the blocks, um, while at the same time having transparency into that data. It's just mostly by way of tokenizing the data rather than actually putting the IDs on there. So you would use the same way that tokens work or tokenized data works in a database. You use the same kind of approach for blockchains as for associating transactions back to backend systems, so you don't give away PII data. Would it be difficult to brute force a private key to hack an account? I think it would be, because the way that the hashes are stored, it's a very expensive. Um, it's a very expensive transaction to do that. So, and it doesn't happen quickly. So even if you were doing like a DDoS approach to the Ethereum network, you're gonna have a hard time bringing it down. And also the process of actually trying to do that brute force attack to validate every attempt is going to take much longer than what you could do if you're running it locally. So I don't, yeah, is it possible? Yeah, not likely though, because it is the way that cryptography is set up. Hack a wallet, yes. Hacking a wallet is one of those things. Yeah, it is possible to hack a wallet. If you were to get access to my machine, you could brute force the wallet. Yes, you could. And that private key data is stored on the wallet. Now, that doesn't give you access to the entire blockchain, of course, but yeah, you could brute force the wallet. But the cryptography on the wallet is typically just a password. So, again, if you're going to use a wallet application, um, then you have to guard that secret rather well, use the long passwords and so on and so forth, just like you would any other kind of personal data that you store on your computer or your device. How is the consensus on validating a hash transaction is it reached? How is the node participating in the consensus, or how are they selected? That's a good question, and it gets really down into the weeds of the game theory that's applied under the hood of a blockchain. And I mean, it's a really I don't have a really good answer for you, because a lot of it is pretty complicated game theory that's been applied to this, and I don't really, truth be told, I don't really have a good grasp of it per se. But I mean, I do know that it's using the same way that an AI algorithm chooses the next move in chess when you're playing a chess game against a human and so on. It uses that same kind of game theory applied to electing people on the blockchain to actually process those transactions. Now, I don't have the technical details, but it essentially works the same way that does. And the consensus is reached by probabilistic approaches and by way of game theory. And so you don't necessarily have to have a majority to get a consensus using a probabilistic approach, and the way that the way the statistics work and so on. You don't actually have to have like a majority to have the consensus, to know that there is a consensus on the network. You just have to have a good survey of the population in order to not, so you don't have to have a 50% or 51% agree. You just have to have a probabilistic approach to that the transaction's valid from a survey of the nodes on the network. So that's kind of how it works. It's all probabilistically based using game theory. So that's the last question. So we've gone a little bit over, but I think those are excellent questions. Thank you for your time. I hope that if you want some more feedback on this, we're going to be posting this video back on our blog. Please follow me on Twitter, or reach out to me online. By way of Twitter, you can ask questions there, or you can pose those back to us at OneElect, and we can help you with training if you want to do that, or if you want to do something, or let us help you write your apps and get those on blockchains. Thanks. I hope you have a great afternoon, great morning, wherever you may be. And that's all for today.